Number 10. We're going to continue the topic of exponential functions. It says, consider the equation, the exponential function y equals 3 times 0.25 to the x power. So as soon as I see that it's being raised to an exponent of x, that's how I know it's going to be an exponential function. Now I want you to notice we have a 0.25 as our base. Now I mentioned before in the last problem, if your b value, if your base is less than 1, which in this case 0.25 is less than 1, your basic parent function is going to be going down. Now this is not like the last problem because what we've introduced now is we have a coefficient to our base. Now when you have a coefficient to your base, this is going to be a multiplier that's going to move your y-intercept, which before was at 0, 1, is now going to move it to wherever that coefficient says. So that coefficient to your base is going to become your y-intercept. So the first question says, what does 3 represent? Well, the 3 represents where it crosses the y-axis. It's your y-intercept. No longer is it 0, 1 because we have a coefficient to our base. Sketch the graph or sketch what this graph would look like. Well, we kind of have a rough sketch going here. So let's continue that in part B. So if I have my axis, I'm going to use a different color here for the sketch. It's going to be a parent function that goes down. However, this y-intercept is not going to be 1 anymore. It's going to be that 3, that number in front of your base, the coefficient to your base. So this is going to be 0, 3. So that's a rough sketch of what this exponential function will look like. It's going down because the base is less than 1, and it's crossing the y-axis at 3 because that's the number in front of your base. Now, part C says, explain the difference between y equals 3 times 0.25 to the x power, which is what we've been working with, and y equals 3 times 1.25 to the x power. Well, in the first one, you have a b value, a base, that's less than 1. In your second example, you have a b value that's larger than 1. The only difference is the direction that your graph is going to go. So if it's less than 1, your graph is going down. It's going to decrease. If your base is larger than 1, which 1.25 is, it's going to go up. However, they have the same y-intercept of 3. So for a quick note here, I want you to write y equals a b to the x, which is what our exponential function was following. A is your y-intercept. B is going to tell you if your graph should be going down or if your graph should be going up. It's going down if your b value is less than 1, like our original function was in this problem. It's going to be going up like this if your b value is larger than 1. So have those notes. Next question. Number 11, filling the missing parts of the proof below. Now what you're going to be doing is you're going to be solving a normal 2, 3, 4-step equation, a multi-step equation, but you're going to be explaining every step along the way, giving reasons. So here they've given us an equation. Now the first thing that you would want to do is you would want to get rid of the parentheses. So what we would do is we would take the -8 and we would distribute it to both terms. Now you have to know that language, distribute. So once we distribute, we're going to have 3x minus 5 equals -8 times 5 is -40. X, -8 times +6 is a -48. Now, the way that I got from step 1 to step 2 is I distributed. So what you're going to write for the reasons is you're going to write distributive property. Distributive property. Now, the next step, if you're trying to solve this multi-step equation, is you want to get all your x's to one side. Now, I've told you in previous problems, your goal is to take your x's and move them to where there's a larger x value already. Now, right now, there's a larger x value here at 3x. Negative 40, though 40 is a pretty big number, negative 40 is a really small number. So your larger x value is here at 3. So what you would want to do is you would want to add 40 to both sides. Now we have to write that as an actual step. We can't just put it right here in little numbers. So for step 3, we're going to write down 3x minus 5, which is what we had before, and then we're adding 40x to the left and to the right. So these should say little x's as well. So we're going to be adding 40x to the left equals negative 40x minus 48. And again, we're going to be adding 40x to this side. The goal of doing that is that these 40x's are going to cancel on the right. Now, we're going to simplify this. So we're going to actually do the algebra piece here. So we're going to do 3x plus 40x, which gives us 43x minus 5 equals, and on the right, these would have canceled. So all I'm left with on the right is negative 48. Now, what I was doing in step 3 is I was adding the 40x to both sides because we said in step 2 that's what we should do next to get all the x's to one side. So for step 3, what I did here was I added 40x to both sides. So I'm going to write addition property of equality because I kept the equation equal and balanced by adding the same number to both sides. I added the 40x. In step 4, after I actually did the addition, all I really did was simplify. So sometimes you'll see this as equivalent equations, or maybe it'll just say simplify. Next step. Now that I have 43x minus 5 equals negative 48, I want to get rid of that negative 5. So what I want to do is I want to add 5 to both sides. But I need to write a full step for that. So I'm going to rewrite what I have right now on the left, 43x minus 5, but I'm going to add the 5 equals negative 48 plus the 5 to the right as well. Keeping the equation balanced, adding the 5 to both sides. My reasoning for doing that? Well, addition property of equality. I'm adding the 5 to both sides. Addition property of equality. Now I'm going to simplify that. I actually want to add them together. So next step, I'm going to have 43x, the minus 5 and the plus 5 will cancel each other out. So I'm just left with 43x equals negative 48 plus 5. Again, this is where the number line would be very helpful. You're going to keep with the negative number. Negative 48 plus 5 is going to equal negative 43. And what you did was you just simplified step 5. You actually did the addition. So you could write equivalent equations or you could write simplify, just like we did in step 4. So I'm going to write equivalent equations / simplify. Step 7. Now I want to get x by itself. So I want to get rid of the 43 in front of it. So what I want to do is I want to break up the multiplication here by dividing both sides by 43. So I'm going to write 43x divided by 43 equals negative 43 divided by 43. I have to do the same thing to both sides. Now the question is, what am I doing? Well, I'm dividing. So for number 7, I'm going to write down division property of equality, since I'm dividing both sides. Division property of equality. And now lastly, for step 8, since we've divided, we're actually going to simplify. So the 43s are going to cancel here, and you're going to be left with x equals negative 43 divided by a positive 43. You're going to get a negative. 43 divided by 43 is just 1. So x is going to equal negative 1. And again, your reasoning is, well, you're just doing exactly what we did in step 7, which was dividing. So we're just going to, instead of writing the division, we're going to actually just simplify it. It's an equivalent equation. So I'm going to put equivalent equations / simplify. And you're done. Now remember, these proofs, you're just going to go through the normal steps that you would do to solve. You just have to explain what you're doing. Are you adding the same number to both sides? Are you subtracting the same number from both sides? Are you dividing? Are you just simplifying the addition? What are you doing? Tell us what you're doing. Number 12, determine whether each graph below represents a function. Explain why or why not. Now, a function, by definition, is having an x value relate to only one y value. So you want to look through your graphs here, and you want to make sure that for every x value, there's only one y value. Now, you've sometimes heard of something called the vertical line test. The vertical line test. Now, your vertical line test is you're just going to follow through with a vertical line, and you're going to make sure you only cut across one point. So if I take a look starting on the left, and I start thinking about these vertical lines, I've only crossed once, crossed once, crossed once, crossed once. So you want to keep going and make sure you only cross your function once. Now, notice when we get here, we do have 2 points. However, since this is hollow, okay, or in other words, empty, that means this point is not part of our function. For the 4, the only matching y value, the only output to your input of 4 is going to be this point right here, 4, 5. So far, yes, this does pass the vertical line test. You only have a valid point right there. Let's take a look at our next graph. Kind of drawing our lines in our minds. Okay, we've only crossed once. This looks like an issue right here, but again, notice, empty circle. So you only have this point matching up the negative 1x value. So for negative 1, your y value is 1, and only 1. Keep going. Now this looks like an issue right here. Both of these are hollow. However, look at the bottom. There is a good valid point right here. So for your 1x value, you have negative 2 as your y value. So 1, negative 2 is your point. Going through the rest, it passes my vertical line test. So both of these are functions. Yes, this is a function. Same thing for the second one. Yes, this is a function. So the vertical line test will allow you to check if something's a function. You only want to cross your graph once as you create your vertical lines, because that means there's only one y value that matches up with your x value. Let's move on. Number 13, solve. Now that looks like a pretty messy equation. However, the only reason it looks messy to you is because of the 4 denominator. Now your goal should be, well, if I can get rid of the 4, then I'm going to be good. This is going to become a much simpler equation. So let's figure out a way to get rid of the 4. What you want to do, since both of them are 4, you can multiply both sides by 4 to get rid of the fact that it's being divided by 4. Now in the future, we're going to look at problems where it's not both 4. And what you want to do is find the lowest common multiple to get rid of that 4. So in this case, since it made it easy for us, we're going to multiply the right by, not by 8, sorry, by 4. And then the left by 4. Now on the left, the 2 4s are going to cancel. So we're going to be left with 3. And you don't touch anything inside of the parentheses. 7x minus 2 equals. On the right side, again, the 4s are going to cancel. 2 times 5x. Now we're going to work with a normal multi-step equation because we got rid of the 4 denominators that were throwing us off in the beginning. Now to get rid of the parentheses, we're going to distribute. So on the left, we're going to multiply 3 times the 7 and 3 times the negative 2. 3 times 7 is 21x. 3 times the negative 2 is negative 6. Equals 2 times the 5x is 2 times 5, which is 10x. Now, I usually at this step would want to bring the 10x, which is my smaller x term, over to the left. However, since the x is pretty isolated on the right, I'm going to do something different this time. I'm going to subtract 21x from both sides. It's going to make the 21x's cancel on the left. We'll be left with negative 6 equals 10 minus 21. Again, you want to think about your number line. Hopefully you've had it drawn. 10. Subtracting 21 means you're going to go 21 to the left. And you're going to end up at negative 11. So 10 minus 21 is negative 11x. Now we want to get the x by itself. So what we're going to do is we're going to break up the multiplication between the negative 11 and the x by dividing both sides by negative 11, because that's what we want to get rid of. The negative 11s will cancel. Negative 6 divided by negative 11, the 2 negatives cancel, and we're left with 6 over 11 positive is equal to x. Or x equals 6 over 11. You can express this as a mixed number. You can't express this as a mixed number. And we can't simplify this any further because 6 and 11, they don't have any common factors. So x equals 6 over 11. Final answer, and this answer is exact. Next question.